Hello everyone. So now covering the true random number generator. Now we will start with the pseudo random number generator. So so what is pseudo random number generator? How it's different from true random generator, and we will see the some real time algorithm of the pseudo random generator in the coming time. Okay, cool. So pseudo random before we saw the drawback of the true random generator is like we can't use the generated one key. अगर हम कुछ key generate कर लें, we can't use it further. Like हम लोग बाद में उसको use नहीं करते. It can be used only once. And for a longer message, the length of the key should be same as the message length. So to avoid the drawback of that, we use the pseudo random generator. So it generates the key stream from a real key much shorter than the full key stream added to the message. We try to whatever what I told you, like it's generated shorter than the full key stream added to the message. Like it is not the key stream length is not equal to the message length. Okay, cool. We try to make the set of possible seeds the real key values so exhaustive search is impossible to practice. Okay. They are deterministic in nature, like they are like predictable in nature. So I will tell you why it's predictable in nature and how it is done in further coming time. Okay. So we can assume here that like I'm giving you the abstract idea how it is. So what happened here it is we are having the one initial seed here. Initial seed is there. Then what happened like if I want to produce the like if I'm producing some bits like some number I'm producing like n number are there. For each bit there is a some bits are there. So I am given the initial bit. So with this help, I can generate the whole sequence, linear sequence. How? So it's like a having the function, then putting s naught, it will give s1. Then this putting in a function f, like s1, then it's producing s2, and so on like this. So on the basis of one seed, we are producing the coming sequence. So we can assume like there is a function, like example I'm giving, like there is a function like some like a random function is there and 5, 2, 4, 5 SI plus 1, 2, 3, 4, 5, something like modulo 2 to the power 13. Something like function is there to produce some sequence of this number. So it's often, that's why I told you like it's a deterministic in nature. Like for coming value, you are having some like function, like it's predictable what the output will be there, S1. So it's used in a good way also, and I have a drawbacks also. We will see further through the examples, but for right now, we know that it's in some aspect it's way better. It's better than the true random generator, and in some aspect it's not good with the true random generator. Okay, we will see further about this. So moving on further. Uh, so moving on to the next slide. Uh, So next, we will, as I told you that we will discuss one algorithm about the pseudo random number generator. It's a middle square method. So what it say that you are having the initially you take any 4-digit number and then square it, you will get the 8-digit number, and then take the middle 4-digit number. That's our next number. So for example, if I have produced the seed is like 2537. Okay, cool. So now squaring this number, then it produces 2537 the whole square. It will give us 6436369. It's already calculated in my like in my notebook, so you can calculate it for like by yourself. You can check if it's correct or not. Okay. So what happened is that like we are like if I'm having 4-digit number, it will produce a 8-digit number. If not 8-digit number, then we will add zero in prefix, then leading zero we will add. Then we will take the 4-digit number in the middle. Like it's like 1, 2, 3, 4, 5, 6, 7, 8. So अब क्या करेंगे यहाँ पे हम लोग बीच की 4 डिजिट उठा लेंगे, है ना? तो 3 4 है ना? तो like what we will pick up 4 3 6 3. Okay, cool. So 4363. So further on, this will become S1 for us. 4363. Then we will square it, then produce the number S2. Then further on, all the number till Sn, we will produce all the number. So this will be the our coming seed, and for that we will use with the plain text, like we discussed in a previous video about that producing the key streamers. Okay, cool. But okay, this is a middle square method. We will discuss the drawbacks of this in like okay, we will discuss now only what can be the problem we can face here. Any guesses? Just you can pause and guess it. Okay, now I'll tell you what's the problem can be there. So if we are having some like seed, we have seed and we got something we got, and at some ith position, some number came. Anna, some number came. It's possible that all the four digit what I am using can be zero. All can be zero. So further squaring that number can produce again zero. So it will follow zeros, all the zero. So here something halting came in a producing the sequence. Some halting came like a so that's a drawback for this. So for using this method, you should wisely choose the seed, initial seed. You can't choose anything like so. There can be a problem arise that it can be zero in the middle and never changes. So this can be a problem in a middle square method. Okay. So moving on further to the linear congruential generator (LCG). I will pronounce LCG here. So now, what's LCG? So, what LCG is also a pseudo random number generator. So, it's like a this function we will use in a pseudo random number generator. So, where xi is a seed and a is a multiplier. It's like a y equal to mx plus c kind of thing. So, y is a multiplier and a is less than m. M is a modulo kind of thing. So, c is an incrementer. It's like intercept in a coordinate geometry. So this equation we will use for producing the further coming seeds. So how? So one more thing, like I want to discuss here before that this thing. So how to decide that the so bringing some randomness to it, like deciding the seed value, initial value of seed. How you can decide this value? We can use the true random number generator. How? So there is some entropy source is there. So we apply to the true random number generator. True random number generator. Basically, it converts that entropy source to the binary form. Then this true random number generator can act as a source for a pseudo random number generator for a only once. Like it's not like we are using again and again to like we use it in true random number generator. Once it generates the xi, then we can loop it on this and that function we can apply whatever the function we are using. Cool. Okay. This is a source for a true random number for generating xi. Okay. So let's not deviate with the topic and let's continue with the LCG. So what's the plan for using this method? अब इसका mainly use इसमें होता है कि यार हमारे पास मॉड्यूलो m यूज कर रहे हैं. So if you start with some source xi, then you're producing xi plus 1, something like xn. So there will be a chance, like it's sure thing actually, that again the sequence will be repeated. So reusability is there for keys, like for coming streams. So there is a reusability. That's a big thing. That's a good thing for that. But whenever doing like these things, let's discuss this afterward. All the problems afterwards. Let's see some example, like some example we are taking. So assume that we are having xi we take the 7, a equal to 7, and c equal to 0, and m equal to 32. Let's x take it 1 1 1. Sorry for 7. X equal to 1. Like follow this sequence. So what we can do, like if we calculate 7 into 1 plus 0 mod mod 32 will give 7. So next our x1 will be 32. 7, sorry, 7. So now putting 7 into 2 plus 0 into 7 into, sorry, A7, B7, sorry, 7, 7, 7 and 7 is mod of 32. So what we will get 49 is 32. It's kind of, I think it's 17. Yeah. Okay. So continuing this, if you will follow this method, we will see that we will get the cycle 1, 7, 723, 723. So the cycle of 4 we will get to follow the pattern. So we can follow this example. But do you think it's a good randomness? There is a good randomness, is there? Like I don't think there is a good randomness because it's following the 4 period cycle, which is I think which it's not good. Like I think like more the bigger the cycle is there, more accurate is the randomness. I think good randomness is there. तो इसके लिए हम क्या करेंगे कि we will try to make the modulus as big as possible. So we will discuss about this in further coming slide. So let's discuss about this moving on that slide only. So by the previous example, we can tell that M should be large and prime. Try to do that. It should not be like some multiple or that. Try to be have a prime of the closer number to the prime, and it should be large as possible. So we get the bigger cycle. So like randomness is good. Its predictability is very less. So that's a good point about this. And one more thing we should make sure that a hacker should not get the XI. That's why I told you to produce that number randomly, and some number should not be guessable. Like if you got some pattern, some number he guessed M, C, M or some with XI. So chances of getting the pattern to the hacker is very easy. So try to get try not to like mess up it with this. So try to generate random numbers, a big cycle. It will be good uh, for your randomness for LCG. Okay. Now the problem with LCGs are what? Okay. So problem with LCGs are so we will one is a small cycles as we discussed. One more problem is there is like let's suppose some I take some example x naught xo equal to 2 uh, sorry. Okay. So x naught equal to 2 and some equation I am taking sorry x n plus 1 equal to 6 x n plus 1 mod 32. This equation we are taking LCG equation we are taking. Now if I produce the sequence x1 we will get try on your notebook. You will get x1 equal to 2, x2 equal to 13, and following 15, then 27, then 3, then 19. But the problem here is it will so 19 we will get then. So now let's reduce after 19. What the after 19 we will get 16 into 19 plus 1 mod 32. So it's 54, 960, 54, 54, 5, 145, 145, 2, I think it's not correct. 960, 54. I think it's again we will get 19 actually here. So we will see that we will stuck on the same number again and again. That's the problem with the LCG. Like so we carefully we have to choose A, C, M and X naught initial generator. All these four values should be generated very precisely. And there are some values are there for which are like very standard values are took like for generator. For c equal to 0, we can choose a value of a equal to 7 5, and m should be prime number as large as I told you, or closer to the prime number. These are some good values you can use: 7 or 5, c equal to 0, and m some prime numbers like 2 power 13 minus 1, something like prime number is there. Okay. So we completed with our topic LCG also. So in coming video, we will see the cryptographically secure pseudo random bit generator, and some generator we will discuss in the coming further video. So for now, thank you.